till now we have seen DRX active and inactive mode in the RRC inactive and RRC idle state. Uh, because what if we get the what if base station has to transfer the downlink data when the UV is in RRC inactive or RRC idle? With this question, we have seen DRX active and inactive states in RRC inactive and idle state because of this question. But our main motto is to save the power. So for that, what we can do is that at when the base station or when the UE is in RRC connected state, at that time also we can save the power or save the energy. We can save the UE battery by introducing DRX active and inactive at RRC connected state as well. So this is connected mode discontinuous reception. As in the name itself, it is connected, RRC connected, and mode is discontinuous reception. So in RRC connected also, we can see DRX active and inactive states. Means periodically UV has to uh, become active and inactive, so that if we get if we get downlink, if base station has to send the downlink data, UV has to actively get on and off. And yes, there are two main things here: energy efficiency and latency. That is that is the main two problems that we can face here. So if I see in this graph, the DRX active and inactive, uh, DRX active and inactive, they are the period is long, so there is long waiting period here. So here latency becomes very high, and energy efficiency increases, latency becomes very high. So um, the problem here is latency, but energy is saved, power is saved, UV's battery is saved, but latency is high. So the one main hindrance is latency. And then coming to the last graph, DRX active and inactive, there is no long waiting time here, there is short waiting time. DRX active and inactive, that is happening faster. So latency is low, but this fast on and off state of the UV can consume lot of power from the UV. So it is low energy efficiency. So if we have more long waiting time, we are advantageous when it comes to high energy efficiency, but we are at disadvantage uh, at the latency. So if we have shorter DRX period, we are at advantage for latency, but we have to give up energy efficiency. So these are advantages and disadvantages. So we have to design our connected mode discontinuous reception properly. So for that, uh, yeah, in the RRC connected mode, we can combine the DRX short cycle and DRX long cycle. So by combining both these things means we'll not be able to give up the latency also, and will not be able to give up the power or energy efficiency. For example, how that is done here, I can explain like DRX short cycle is there. So DRX short cycle, at the short cycle UV turns on and off very easily. On duration time is there. Uh, on duration time is there. So here this at this stage, that is DRX short cycle, the latency is low and energy efficiency, energy consumption is high. But after this period, Means assume it like that, on duration timer, and this complete on and off duration, it is DRX short cycle. And then that complete, uh, how many DRX short cycle are there, that is DRX short cycle timer. So they are two. DRX short cycle means on and off, the on and off cycle of the DRX, they are two. So this is complete DRX short cycle. Here the latency is low, but energy consumption is high. And soon after that, if we introduce long DRX cycle, of course, we are at disadvantage when it comes to latency, but energy consumption is reduced, or UV's battery is saved here. So both combining both these things and designing RRC connected state according to this is very important. So these are combined, all these are RRC parameters. Okay. So this is a very important concept where we can, we are at advantage when it comes to both latency as well as energy consumption of UV. So uh, if we upgrade our thinking little more, so at the RRC connected state, assume that of course physical downlink control channel with downlink scheduling, physical down control physical downlink control channel, uh, base station, it has to schedule, if the base station has to send the downlink data to UV, at that time PDCCH with downlink scheduling, that is triggered. So this event is UV, it will receive the PDCCH with the downlink scheduling assignment. So for that, earlier we had a standard cycle, like DRX active has to be for this amount of time, or DRX inactive has to be this for this amount of time. We had a standard graph, standard DRX cycle, or standard on timer. But as we upgrade ourselves, if we get that PDCCH with the downlink scheduling from base station to UV, uh, this is smart way of handling the things. Like if we get PDCCH with downlink scheduling, automatically UV will increase its DRX inactivity timer. Means it is open to get that downlink data for more timer, more increased timer. So if we have got here PDCCH with downlink scheduling as a one signal from base station, and if we also get another signal here, assume the imaginary signal, we get PDCCH with downlink scheduling here as well. So there is DRX inactivity timer can start from here as well, here also, imaginary. Means all these things can happen combined. So PDCCH with downlink scheduling, if we get, UV can increase its DRX inactivity timer only because UV is open to getting that downlink data from base station. So these things can happen parallel. Means if we get PDCCH with downlink scheduling, one DRX inactivity timer is active. If we get another PDCCH downlink scheduling in this DRX timer only, at that time also DRX inactivity timer can increase. It can start from there also. So like this, it can happen parallelly. So this is one more advantageous thing when it comes to saving the power of UV. Okay. So okay. So what if that PDCCH downlink data which we get from base station, what if that is error signal? So at that time, sorry for inconvenience. This NAC signal will go from UV to base station. Okay, what if the signal, what if the downlink data we get, that is erroneous? So at that time we have a negative acknowledgement from the UV to base station, because that is error. We are appealing for retransmission, that is negative acknowledgement. So at that time we have another timer called as a DRX HARC RTT timer. So HARC and RTT will explain it